This is the screencast for section 4.4, example 3. We're going to fabricate a box. We fabricated some boxes in pre-calculus, and then we graphed them to find probably the maximum volume, and we did second calc max. Now that we're in calculus, we're going to put this box together and then use calculus to find the maximum volume. So an open top box is to be made by cutting congruent squares of side length x from the corners of a 20 by 25 sheet of tin and bending up the sides. So basically you've got these boxes that are being cut out here, and then you're bending up all of these sides to create this box down here that does not have a top to it. How large should the squares be to make the box hold as much as possible? What is the resulting maximum volume? So we have two questions we're answering here, but we can find it all with the same process. So first, I need to find the volume of the box, which is length times width times height. And the length of the box is going to be 25 inches minus 2x. The width is going to be 20 inches minus the 2x's we cut out. And then the height of it is going to be that length of x that we cut out. So after some multiplying and simplifying, I get that the volume can be expressed by 4x cubed minus 90x squared plus 500x. And then if I find the first derivative of that and it's zeros, I will be able to test that on a number line. Now I definitely use my calculator to find out the zeros of the first derivative because they were, it was not easily factorable. You could use quadratic formula too. Either one would have worked in this case. Now I get 3.68 and 11.32. So I'm going to go back to my original box. If you remember from pre-calc, sometimes we find an extraneous solution here. 3.68 is no problem. I can cut out 3.68 inches from either side of this and still have a width of a box. But 11.32, this one side is only 20 inches long. If I cut out two 11-inch pieces, that's 22 inches. I don't even have enough. So I can't use 11.32 inches. I'm only going to use the 3.68. So that's what I'm going to test on the number line of V prime. And I get that there is a maximum at 3.68 inches. So if I cut out 3.68 by 3.68 inch squares, the box will have the volume then, if I plug 3.68 into the volume equation, it will have 820.853 cubic inches of volume. Then now try problem number 7. It says you're planning to make an open rectangular box from an 8 by 15 inch piece of cardboard by cutting congruent squares from the corners and folding up the sides. What are the dimensions of the box of the largest volume you can make this way, and what is its volume? Alright, so I'm going to draw a picture first to represent the information that I have. So I have this 18 by 15 piece of, cardboard, and I'm going to be cutting out little squares on each corner and then folding those up to make my box. So I got to find out what those dimensions are for those corners. So very similar to the last time, my box is going to have a volume of x for the height. Then one of the dimensions is going to be 8 minus 2 times that x dimension. The other side is going to be 15 minus 2 times that x dimension because we're cutting out 2 x's, one from each side. So I'll do some multiplication and find the derivative. So now I got the first derivative and I'm looking to find its zeros. This is a quadratic, so I could use quadratic formula. I could factor if you're so inclined. You can also use the calculator. Now notice my calculator does not go all the way out to infinity. I actually set the window on purpose. The maximum I can cut out of this box would be a 4, actually less than 4 4-inch piece, because if I cut out more than 4 inches, this side of 8 wouldn't work. So I just cut my window down here at 5 so I can see that the only value that really works for cutting out of x is 5/3 inches, so 1 2/3 inches. So that's the only number I'm going to put on my number line. And after testing, I can see that there is a maximum there at 5/3. So to answer the question, what are the dimensions of the box of the largest volume you can make this way, and what is its volume? Okay, well its volume is going to be V of 5/3, which is 90.74 cubic inches. Now the dimensions of the box I'm going to have to plug into each piece. So the height is 5/3, that's just x. The width would then be 4 2/3, 8 minus 2, 5/3. And then the length would be 15 minus 2 times 5/3, and that's 11 2/3 inches. So I've got my box dimensions and my volume right here.